Hello everyone. Now I am going to show you the demo of our master project. As we are working on a network protocol, so this demo is going to be a bit technical and we are really sorry for that. Let me explain this network. So here we have a network with 7 nodes. So when we start our project, all the nodes will start sending extended beacon data. So within this data, every node will calculate the strength vector with other nodes. Okay. Now at some point, master node, I mean here we are considering one as a master node. The master node will initiate the advertisement. So from this log, we can see the master node 1 has started the advertisement procedure, and node ID 5, node ID 4 and node ID 3 2, those nodes receive the master packet, advertising packets. But as you can see, 7 and 6 didn't hear anything from 1. But later on, if we look at much further, the 7 node received the advertising data from node ID 5. So after getting the advertising data from node ID 5, it selected the base node as 5. So this way, the base node is selected. So I can filter the base node selection. So from this log, we can see node ID 2 selected base node 1 because it's pretty near to 1. But node ID 7 selected base node as 5 because 5 is near to 7. So this way, every node will select their base node, and every node will know how the strength vector can be transferred to the node I1. So let's see another log. So here is the routing information, how the strength vector is processed, transferred to node I1. So here, node I6, it sends the strength vector data through node I2 to 1. Now let's see how strength vector is sent from 7. So node ID 7 send the strength vector through 5 to 1. Pretty simple. So what happens when the actual data is received by node ID 1? Let me filter the strength vector. So as you can see, those logs are only printed on node ID 1. Everything is node ID 1. And this strength vector means node ID 4 has this strength vector, node ID 7 has this strength vector, and so on. So this way, node ID 1 will know the strength vector from all nodes. Now, when we have the strength vector from all nodes, now we can think about other unicast processing. Let's say 5, node ID 5 want to send some information from node ID 2, and node ID 7 send some information to node ID 3. So for this, we need to feed this log into Python project. So we run the command with this log only from node ID 1 with this flow 5 to 2 and 7 to 3 with a period of 40. So from using these logs, the strength vector is the PRR and ETX table is calculated. Also, using the sliding window algorithm, the slots are allocated. Here we can see there are some empty slots which can be used for our neighbor data collection protocol. So after run this command, this C file is generated which can be used to set the schedule for unicast data. And here we calculated one matrix to provide the empty slots. Now let's go to the project again. Let's start this. As you can see, this project we already started a long time ago, like 10 minutes already passed, and we can see if the unicast data is received or not. So those are the bytes which is received from 2 to let's pause it here, because let's say node ID 7 receives some data from node ID 3. Oh, sorry, the other way around. Node ID 3 receives some data from node ID 7, and node ID 2 receives some data from node ID 5. So what's going on with other processing? Let's say advertisement. As you can see, after 10 minutes, the advertisement is still going on. What happens to the actual data? As you can see, the actual data is always getting on. And what happens to the strain vector? Uh, Sorry about that. So the strain vector is collected in after some moment. So this way, everything is working in a single project. Thank you for the presentation.